In April 1912, the world watched in horror as the massive Titanic disappeared into the frozen Atlantic abyss. The tragedy proved that even the strongest steel is helpless against the crushing weight of the deep sea. For over a century, engineers believed that a hole in a metal hull meant a certain death sentence for any vessel. But inside a laboratory at the University of Rochester, a scientific miracle has just rewritten the laws of physics. Scientists have engineered a piece of aluminum that refuses to stay submerged no matter how much force you apply. This is not a digital illusion or a simple magic trick involving hidden magnets. This is the dawn of the unsinkable metal revolution that could save thousands of lives at sea. The inspiration for this breakthrough did not come from a computer screen, but from the natural world. Professor Chunlei Guo studied the unique survival skills of the diving bell spider and the resilient fire ant. These tiny insects trap a protective bubble of air around their bodies to stay dry while they hunt underwater. The Rochester team used a high-powered femtosecond laser to replicate this biological wonder on a metal surface. A femtosecond laser pulses at incredible speeds to carve microscopic patterns into the shiny aluminum disc. These intricate grooves are so small that the human eye can only see a smooth gray texture. But to a single drop of water, these nanostructures represent an impenetrable fortress of air and resistance. The treated metal becomes super-hydrophobic, which means it repels liquid with an intense physical force. When a metal disc is plunged into a water tank, a permanent cushion of air remains trapped inside the grooves. This invisible layer of air acts like 1,000 tiny life jackets, providing constant upward lift. The researchers performed a brutal durability test to prove the strength of their new discovery. They submerged the treated aluminum and held it down with heavy lead weights for several long months. When the weights were finally removed, the metal shot back to the surface like a cork from a bottle. The air bubbles remained trapped in the nanostructures even after prolonged exposure to the deep. Typical waterproof sprays eventually wear off or lose their power when the surface is scratched. However, the Rochester metal can be punctured with multiple holes or damaged with deep jagged cuts. The air remains trapped in the remaining intact structures to keep the entire object floating above the waves. Imagine a massive cargo ship that can collide with a jagged reef and remain perfectly buoyant despite a hole. A ship built with this technology would experience significantly less friction as it moves through the waves. The layer of air between the hull and the liquid acts as a lubricant that allows the vessel to glide. This discovery would lead to a massive increase in fuel efficiency for the global shipping industry. The environmental impact of sinking oil tankers leaking toxic sludge into coral reefs could be virtually eliminated. Beyond the ocean, this technology has incredible potential for the future of urban infrastructure. Coastal cities facing rising sea levels could build floating buildings and waterproof power stations. The laser technique is being tested on other materials like glass and plastic to expand the possibilities. We are moving toward a world where the fear of drowning or losing precious cargo is a thing of the past. The same technology that keeps a spider dry in a pond is now keeping our heaviest machines afloat. The manufacturing process is currently expensive due to the specialized laser equipment and time required. But as the process scales up, we will see this material in everything from cars to smartphones. It is a profound reminder that the most complex engineering solutions often come from the smallest insects. Nature has been using these nanostructures for millions of years to survive in wet environments. Now humanity has finally unlocked the code to master the water and conquer the deep. The legacy of the Titanic serves as a haunting reminder of the limitations of our past engineering. But the unsinkable metal of the University of Rochester is a beacon of hope for a safer future. We are no longer at the mercy of the weight of steel and the crushing power of the ocean. The sea is no longer a graveyard for our machines, but a vast highway for eternal exploration. The era of the sinking ship is coming to an end as we sail into the age of the unsinkable.